So chapter 3.5 example 16, let's read the question, go through, pick out the key terms. So for a geometric series, first term A, common ratio R, S4, the sum of the first four terms equals 15. And the sum to infinity equals 16. Find the possible values of R. So let's take the key statements that we've got there. S4 equals 15. And the key thing is recognising the notation, what that S4 means. So that is the sum of the first four terms. So our equation that we want is Sn equals, it's a geometric series, so it's A lots of 1 minus r to the n over 1 minus r. Why did I pick that form of the equation rather than Sn equals A lots of r to the n minus 1 over r minus 1? Well, the answer is that we've got a sum to infinity, so that tells me that the modulus of r must be less than 1. So I prefer to use this one. The modulus of r is less than 1, and this one we tend to use when the modulus of r is greater than 1. So this form is the one we're going to use. So now we're going to substitute in. So S4 is going to be equal to A lots of 1 minus r to the 4 over 1 minus r equals 15. We're also told that the sum to infinity is 16. So the sum to infinity equation, which you should have learnt, so the sum to infinity is equal to A over 1 minus r, provided the modulus of r is less than 1. Okay, so we've got three results there that we need to be familiar with. So from the second part of our statement, sum to infinity equals 16, we're going to get sum to infinity equals A over 1 minus r. So 16 equals A over 1 minus r. Right, now, that is quite useful to us, but you need a little bit of insight. Look at it carefully. What can we see? We've got A over 1 minus r there, and we've got A over 1 minus r there. So we can substitute in for A over 1 minus r to give 16 lots of 1 minus r to the 4 is equal to 15. Multiply out, 16 minus 16 lots of r to the 4 equals 15. Make the subject positive, etc. 1 equals 16 r to the 4. So r to the 4 equals 1/16. The fourth root of 1/16. It's like square rooting, so we're going to get a half plus or minus. That's why I say it's like square rooting, because if you take half to the power 4, you get 1/16. If you take negative a half to the power 4, you also get 1/16, because negative times a negative is positive, times a negative is negative, and then the third one, negative, makes it positive again. Hope that's clear. Okay, now we've got r as possible values of r, so that's quite good. I've just checked the question here, find the possible values of r, and we've got 2, so that's good. Part B, given that all the terms in the series are positive, find the value of a. So part B, all terms positive. Therefore, r must equal a half. Otherwise, the signs are going to oscillate from positive to negative. So we've now got r equals a half, so we can substitute into our sum to infinity equation. We could choose the other one, but the sum to infinity one is the easiest one because there are less parts to it. So we were told the sum to infinity, I think, was 16, if I remember correctly. Yes. So 16 is equal to a over 1, take away, substitute in the r, a half. So we've got 16 is a over a half, multiply a equals 8.